Imagine a world where particles can be in two places at the same time, where observing something changes its reality, and where the very fabric of existence behaves in ways that defy common sense. Welcome to the world of quantum mechanics, the most mysterious and fascinating branch of physics that governs the smallest building blocks of our universe. In this episode, we'll break down the fundamental principles of quantum mechanics, explain why it's so weird, and show you how this invisible world shapes our reality. Buckle up, because this is going to blow your mind. Classical versus quantum. What's the difference? Before we dive into quantum strangeness, let's compare it to classical physics, the physics that governs our everyday life. In classical physics, objects follow clear rules. If you throw a ball, it moves in a predictable path. If you push a chair, it moves in one direction. The universe seems logical, deterministic, and easy to understand. But in the quantum world, things are very different. Particles don't just exist in one place at a time. They exist in multiple places at once. They don't just move in a straight path. They behave like both waves and particles simultaneously. And perhaps the strangest part? Just looking at them changes their behavior. The double-slit experiment, reality is an illusion. One of the most famous experiments in quantum physics is the double-slit experiment. And it reveals something truly bizarre about the nature of reality. Here's how it works. Scientists took a simple experiment, firing tiny particles like electrons at a screen through two slits. Logically, you'd expect them to go through one slit or the other, right? But that's not what happens. Instead of behaving like tiny solid balls, these particles create an interference pattern. The same pattern you'd get if they were waves instead of particles. This means each particle is somehow going through both slits at the same time. But here's where it gets even weirder. When scientists placed a detector to see which slit each particle went through, the interference pattern disappeared. The particles suddenly behaved like tiny balls again, choosing only one slit. In other words, the act of observing changed reality itself. This is called the observer effect, and it suggests that quantum particles don't have a definite state until they are observed. But why? That's one of the biggest mysteries in quantum physics. Superposition, being in two places at once. The double-slit experiment shows us a concept called superposition. The idea that a particle can exist in multiple states at the same time until it is observed. Think of it like flipping a coin. Normally, the coin is either heads or tails. But in the quantum world, the coin doesn't land on either side. Instead, it exists in both states simultaneously until someone actually looks at it. A real-world application of superposition is in quantum computers, which use quantum bits, or qubits, that can exist as both 0 and 1 at the same time. This makes quantum computers vastly more powerful than traditional computers. Quantum entanglement, spooky action at a distance. Another strange quantum phenomenon is entanglement, what Einstein famously called spooky action at a distance. Imagine you have two quantum particles that become entangled, no matter how far apart they are. Even if one is on Earth and the other is on the other side of the galaxy, changing the state of one particle instantly affects the other. This breaks everything we thought we knew about physics. How can information travel faster than the speed of light? Is the universe secretly connected in ways we don't understand? Scientists are still trying to figure this out. Entanglement has huge implications for the future of quantum communication and cryptography, potentially making unhackable communication a reality. What does this mean for reality? So, what does all of this mean for our understanding of the universe? Quantum mechanics suggests that reality, as we know it, is not fixed. It's influenced by observation, probability, and interactions at the quantum level. Some scientists even believe that quantum mechanics might help explain the nature of consciousness, the possibility of parallel universes, and the fundamental structure of reality itself. While we still don't have all the answers, one thing is certain: the quantum world is stranger than we ever imagined. Quantum mechanics has completely changed our understanding of the universe, but we've only just scratched the surface. In the next episode, we'll dive deeper into one of the most famous quantum paradoxes, Schrödinger's cat. Is it really alive and dead at the same time? If you enjoyed this mind-blowing journey into quantum mechanics, make sure to like, subscribe, and hit the notification bell so you don't miss the next episode. Let me know in the comments, which quantum concept fascinates you the most? Until next time, keep questioning reality.